All right, guys, so this is the video for 10.2. In this video, we're going to start talking about angles of circles, especially central angles. But we'll get to that here in a minute. So just to warm up, we're going to do 1, 2, and 3. So on number 1, I want you to take note that we're talking about percentages. Okay, so anytime we're talking about percentages, the whole thing should add to 100, right? So I could just set up an equation, x plus 34 plus 23 plus 14 equals 100. Okay, so if I add these right here up, I get x plus 71 equals 100. Subtract 71 from both sides, I get x equals 29%. Okay, so this here is 29% of the circle. All right, now notice here I'm talking about degrees. So think of a circle. This may be new, you may know it. If we go all the way around a circle, we have a total of 360 degrees. So 61 plus x plus y has to equal 360. Okay, so some of you are thinking, well, how the heck do we find when we have two variables and we don't know anything? Well, notice this here would be a half a circle, right? So if the whole circle is 360, this y would be half that, which is 180. Okay, and then the 61 plus x is the other half, so would add to 180, so minus 61, I get x equals 119 degrees. Make sure you get the units because very clearly percents and degrees are different. All right, go ahead and try number 3 on your own, and then we'll go over it. All right, so you should have seen that this is in degrees, and an entire circle is 360 degrees. So if you add each one of these terms up, they would equal 360. Okay, and so then when you do a little bit of algebra, you should get that x equals 35. All right, guys, so like section 1, we have a whole page of vocab. Now, some of these you might know, some of these you probably won't know, but that's okay because we'll learn them. All right, so a semicircle is simply an arc with endpoints that are endpoints of a diameter. Okay, and a semicircle is a half of a circle. So if I have a circle here, and then I have my diameter, this would be a semicircle, okay? It's like a half a circle. So think of like a hemisphere when it comes to the globe, okay? It's halfway through, okay? Now a central angle is an angle whose vertex is the center of the circle, okay? So if we have a circle, here's the center. This would be a central angle right here because this vertex here is the center of the circle. Okay, so any angle whose vertex is the center of the circle would be a central angle. All right, guys, so something I probably should have put on here would be arc. And an arc would be a piece or a part of the circumference of a circle. Okay, so think of like any piece that you draw here, this would be an arc. This would be an arc. This would be an arc. Okay, so any small piece around here would be an arc. Okay, so then a minor arc would simply be an arc that has a measure of less than 180 degrees. Okay, so it's smaller than a semicircle. And then a major arc, as you could probably guess, is more than 180 degrees, so it's larger than a semicircle. Adjacent arcs are arcs of a circle that have one point in common, and they are side by side. Guys, that's kind of what this word adjacent refers to, is they're side by side or they're next to each other. All right, congruent arcs. So congruent arcs are arcs that have both the same measure and, highlighted and uppercase letters, and are of the same circle or of congruent circles. Okay, and we'll do some example of these and it'll make more sense when we do that. Similar arcs are simply arcs that have the same measure. And then congruent circles are defined as as circles that have the same radius. All right, guys, so we're going to talk about arc measures. And when we're talking about arcs, remember we're talking about any part of the outside or the circumference of the circle. Okay, so like arc AB right here, if this central angle is 50 degrees, this arc right here is also going to be 50 degrees. And as we talked about when we did our warm-up problems, all the way around is 360 degrees. Okay, so halfway around would be 180, a fourth of the way around would be 90, and so on and so forth. Okay, so let's use that and do example 1. Okay, so find the measure of each arc of, and remember we call this circle P, where RT is the diameter. So it tells you that RT is a diameter because that means it cuts it in half. So this here, guys, we know is half the circle or is 180 degrees. Now when we name these arcs, it's kind of hard because we don't always go like clockwise or always go counterclockwise. We go, if there's 2 letters, we go the shortest arc. Okay, so for example, the first one we have RS. Okay, so we could say, well, RS is from here to here, or we could say RS is from here all the way around to here. Okay, we're going to go the shortest way. And because we're going the shortest way, we're talking about this arc here, RS. Now, what we learned above is that the measure of this arc is the same as the measure of this central angle. So the measure of arc RS is 110 degrees. I'm going to write here, the measure of the arc, measure of the intercepted arc is the same as the measure of its central angle. All right, so here we want to find the measure of RTS. Okay, now we're going to go, when there's 3 letters, we go in the order in which they come. So RTS, if we go this way, would be RST. So we're going to go this way, RTS. Okay, now if you look, this is basically the entire arc without this arc in blue. So we could find that just by doing 360 minus 110, and that would give us 250 degrees. Okay, last but not least, arc, RST, and guys, notice this arc symbol at the top. Okay, so arc RST, we're going to go in order, so R to S to T. Well, if the upper part's 180, this has to be the remainder of 360, so 360 minus 180 is also 180 degrees. All right, guys. So the arc addition postulate tells us that if we have 2 adjacent arcs, then we can just add them together. Okay, and we kind of did this the time before, or the example before. So if I look at this, I want to find arc GE. So arc GE, we're going to go the shortest distance. This here is the shortest distance. Okay, so we would find GE by adding GH plus HE, which is 40, plus 80, which is 120. Okay, so I want you to go ahead and do B and C on your own, and then we'll go over them. All right, so this is what you should have gotten on B and C. All right, guys, we have a couple theorems here. So this first theorem says, in the same circle or of congruent circles, two minor arcs are congruent if and only if their central angles are congruent. Okay, so because this angle and this angle are congruent, that means that this arc here and this arc here have to be congruent. Likewise, if we just knew the arcs were congruent, that would mean that the central angles are congruent. Okay, and anytime you have something like this, you should know they're congruent because these are also vertical angles, guys. All right, the one before it, the congruent circles theorem, tells us that two circles are congruent if and only if they have the same radius. We kind of already went over this, so this shouldn't be a big surprise. All right, so let's do a couple of examples. We want to know if the red arcs are congruent. And I know you don't have red on your paper, so you might want to like highlight them or whatever. So I want you to remember that congruent arcs must have two properties. They have to have the same measure and I believe we wrote this in our vocab. Yes, right here. And they have to be either a member of the same circle or congruent circles. Okay, so both of these have to apply. Okay, so if I look at A, arc DC and arc EF, both have a measure of 80 degrees, and they are the same circle, so I can say yes, they are both 80 degrees and of the same circle. All right, so B. If I look at these, this is a right angle. So this arc RS is 90 degrees and TU is 90 degrees. Okay, so yes, they have the same measure, but they are not of the same circle. They're two different circles, and these circles sure are not congruent. So these arcs would not be congruent arcs. I'm going to write same measure, but not congruent circles. All right, then if I look at C, well, 95 and 95, so this is 95 degrees, this is 95 degrees. So they have the same measure. They're not of the same circle, but notice the radii, or the radius of each circle is congruent. So these circles are congruent circles. So that does check that box right here. So I can say that yes, these are congruent arcs because both are 95 degrees and are a part of congruent circles. All right, I want you to go ahead and do both 7 and 8 on your own, and then we'll go over them. All right, so if I look here at number 7, I notice both of these red arcs have 145 degree measure, okay? And I can tell that the circles are congruent because each radius here and here have the common single hash mark, so these have to be congruent circles. So yes, they are congruent because they both have the same measure, and they are of congruent circles. Okay, 8, 120 degrees and 120 degrees, so I checked that box. But notice that the radius of this circle on the left is 5 and the radius of the one on the right is 4. So these are not congruent circles, and therefore the the arcs are not congruent. They do have the same measure, but the circles are not congruent. All right, so that brings us to our very, very last theorem of this section, and it is the similar circles theorem, and it's short and sweet. All it says is that all circles are similar. Okay, so I want you to take a minute, and I want you to think about this, and I want you to think about why this is true. You should be able to rationalize this in your brain is why this is true. Know what you know about similarity.